This is going to be a quick video on the topic of trig values. Trig values. You're going to get some trig value with sine, cosine, tangent, cosecant, secant, and cotangent on some the other practice problems, but I want to bring up problems that look like this. So sine of cosine inverse of 1/2. I want to break it down and show you what this really means. Sine of cosine inverse 1/2. This means that this is actually the input for sine, which means this value here has to be something in radians. So if that means that everything cosine inverse, that -1 is an inverse, and it undoes the cosine function. It's kind of like log functions undo exponential functions, cosine inverse functions undo cosine functions. So to release this thing in the parentheses, you have to figure out, okay, this is what angle of cosine in radians. In calculus, we're only working in radians, is 1/2. Here's how you do this. Draw triangles on your SAT 2. Just if you know how to draw triangles, you're pretty much good for all the trig part. So here's a right triangle. So, ka, to, a. When I do these problems, I usually use the unit circle. That's why I have 3 unit circles pasted around my room. But like this one is, I'll work with what you guys got. You guys know SOHCAHTOA. So the ka, the cosine, is the adjacent over the hypotenuse. The adjacent 1 over the hypotenuse. If you did your Pythagorean theorem, you did 2 squared minus 1 squared and the square root of that, or you know that this is a special right triangle, 1, 2, root 3. You should memorize your special right triangles. This is a 1, 2, root 3. This is a 30, 60, 90 right triangle. Okay, now you have a triangle. Now, this in blue, this input says what angle makes this cosine 1/2? And it's this angle theta. I know what this angle is because I know it's a 30, 60 right triangle. You don't actually have to know what the angle is because all this is now saying is what is the sine or the opposite over the adjacent of this theta, whatever this theta is. We don't know what it is. So the opposite is root 3 and the adjacent is 2. So even though looking at this 1/2, I knew what the theta was, you don't have to know. You just have to know that it's the same triangle. You just need the sine ratio of the same triangle as this cosine ratio. That's all I want to bring up. The other option was to do it on the unit circle, and just very briefly, what I would do is since I know that cosine is the x values on the unit circle, I would scan where does it say 1/2, and then I would read the sine value next to it. And this only works for sine and cosine unless you know what you're looking for. So I actually always recommend this triangle. Okay, bye.